Hello people, welcome back to my channel TheTalk. Today we are going to continue with the polynomials chapter. So this is the exercise 2.2. We will continue with the questions on this topic. Last class we were discussing about how to find out the zeros of a polynomial and the relationship between the zeros of the polynomial, the sum of roots, the product of roots. So we will revisit them first. So sum of roots alpha plus beta, so this is to a quadratic equation in the form ax square plus bx plus c. So sum of roots is minus b by a, product of roots is alpha beta, that is c by a. If it is a cubic equation, the polynomial equation's general form ax cube plus bx square plus cx plus d. So sum of roots alpha plus beta is minus b by a. Sum of product of the consecutive roots alpha beta plus beta gamma plus gamma alpha is c by a, and product of the roots alpha beta gamma is d by a. So this is how we express the relation of the sum of roots, the product of. Let us get into solving the exercise 2.2. The first question says, I have done a detailed video explaining the basics of polynomials and the first exercise 2.1 was covered in the previous video. I'll be providing a link, so please do refer to the link if you haven't watched the video yet. So this is the first question in the exercise 2.2, and the question says, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So zero of a polynomial is something, the value of x for which the equation is being satisfied, and coefficients are the, suppose we consider the general form as of the polynomial equation as ax square plus bx plus c equals to 0. So coefficients of the variables in this expression are a, b and c. And the 0 is the value of x for which the equation is going to become 0. So let's remember this as the general form for a polynomial equation. And before going to the questions, so alpha plus beta, sum of roots is minus b by a, alpha beta is c by a. So minus b is nothing but the coefficient of x by coefficient of x square, and c is the constant divided by coefficient of x square. So these two are the two important things that we will be using to verify every question in the exercise. So starting with the first question, x square minus 2x minus 8. So if we kind of factorize this, the first factors that we are going to get, that we will look at the constant. So constant is 8 and its sign is negative. So when we express it in the form of product, it's going to be 4 and 2. This is going to be x square minus 4x plus 2 x minus 8. This can be further factorized as, because x can be picked out as common, x minus 4. Now the common factor being x minus 4, this will turn x plus 2. So therefore the roots, alpha is one root, so the roots of it are going to be minus 4, comma minus 2. So we will let to be, you will let x square minus 2x minus 8 be p of x. So we will verify this, that is sum of roots is the first verification, that is alpha plus beta, which is going to negative of quotient of x by quotient of x square, that is b by a. But before going to this, let us verify alpha plus beta. Alpha plus beta is 4 minus 2. So this is nothing but 2. Minus b by a, how much is minus b by a equal to? Minus b by a is also equal to negative of negative 2 by 1. Because quotient of x is minus 2, quotient of x square is 1. So this is equal to 2. This is proved. Then product of zeros, alpha beta. So product of zeros is 4 multiplied by minus 2, that is minus 8. This is nothing but c by a. So c is minus 8 by the quotient of x square is 1. So that is equal to minus 8 by 1, that is equal to minus 8. Coming to the next question. So we will first of all, we will let the given expression equals to p of x, and upon factorization of the 2s is a common factor for this. So when 4s square minus 4s plus 1 is factorized, it becomes 4s square minus 2s plus 1, and 2s can be picked up as common. It becomes 2s minus 1. So negative 1 when it's taken as common, 2s minus 1. So therefore roots of p of x will be equal to 1 by 2 and 1 by 2. So first sum of zeros, which is alpha plus beta, that is equal to 1 by 2 plus 1 by 2. 2 by 2 and you're getting it as 1. According to the equation, we have alpha plus beta is minus b by a. This is going to become as negative of negative 4 by 4, which is 1. Then the product of zeros, which is alpha beta, that is 1 by 2 multiplied by 1 by 2, which will be 1 upon 4. This is equal to c upon a. That is nothing but the constant 1 upon the quotient of x squared, 1 upon 4. Going to the next question, assume that the expression given 6x square minus 3 minus 7x equals to p of x. Now rearranging the terms, this expression is going to become 6x square minus 7x minus 3. Upon factorization of it by splitting the middle term, this is going to become 6x square minus 9x, because product of 6 and 3 is 18. This can further be expressed in the form of factors as 2 multiplied by 3 and 3, and you wanted the difference as 7. So the factors we take are 9 and 2, minus 9x plus 2x minus 3. From this 3x can be picked up as common. Then 2x minus 3 is the common factor and the other factor is 3x plus 1. So the roots are 3 upon 2 and minus 1 upon 3. So now the first step in verification is the sum of roots. Alpha plus beta is 3 upon 2 minus 1 upon 3. So the LCM is 6. This is going to be 3 times 3 minus 1 multiplied by 2. So this is 9 minus 2 upon 6. It's nothing but 7 upon 6. So according to the relation that we have, alpha plus beta is negative of the quotient of x by the quotient of x square. So that is minus of minus 7 upon 6. So minus of minus is plus and it is 7 upon 6, and this is also verified. So going with the product of roots now. So the two roots of the equation are 3 upon 2 multiplied by minus 1 upon 3. Upon simplifying this, we will be getting the answer as minus 1 upon 2. Now verifying it with the actual equation, alpha beta is product of the roots is the constant divided by the quotient of x square. So this is going to be the constant, which is minus 3 upon 6, the quotient of x square. Upon simplification it becomes 1 upon 2. Let's continue with the next question. 4u square plus 8u. So assuming this expression as p of x. So on simplifying this, 4u is the only common factor that can be brought. This can be written as 4u plus 0 and u plus 2. So the roots of it are 0, minus sum of roots, which is alpha plus beta, that is 0 minus 2, which is equal to minus 2. Now we will verify the relation that alpha plus beta, which equals minus b by a, that is the coefficient of u here, which is minus 8, upon quotient of u square, which is 4, it becomes equal to minus 2. Then the product of roots alpha beta, which is going to be 0 multiplied by minus 2, which is 0. So according to the relation, alpha beta is the constant divided by quotient of x square. As there is no constant, it is 0. So 0 divided by any number is 0, which is also equal to 0. Hence it is verified. The next question says find a quadratic polynomial, each with the given numbers as sum and product of its zeros respectively. We are given with the sum of the roots, that is alpha plus beta is given, and the product of the roots alpha beta is given. So basing upon this, we are supposed to find out the polynomial expression having the roots given in the question. Let's start with the first question. So the roots are, the sum of the roots is given that 1 upon 4 and the product of the roots is minus 1. So we consider the general form of a polynomial expression, that is ax square plus bx plus c. So sum of the roots alpha beta given is 1 upon 4 and product of the roots alpha beta is minus 1. So according to the general relation, alpha plus beta is always equal to minus b by a, that is negative of the quotient of x divided by the quotient of x square. Let's consider these relations at this place. So when you substitute it, it is going to become minus b by a and this is c by a. So this means that b minus b equals to 1. So b is nothing but minus, b is like 1, minus of minus 1 which will become 1, a is 4 and c is negative of a which is minus 4. So the equation basing on ABC, the polynomial equation is going to become 4x square plus x minus 4. Let us consider the second question now. So p of x equals to ax square plus bx plus c. So alpha plus beta given is root 2 and alpha beta given is 1 upon 3. So product of the roots, that is minus b by a. So sum of the roots, that is minus b by a, and product of the roots c by a. My root 2, this can be also written as root 2 upon 1. So b is equal to negative of minus root 2. So that is going to become root 2 minus root 2 and a is 1. C is negative a upon, so that will become 1 upon 3. So c is going to become 1 upon 3. The polynomial equation based on this ABC value is x square minus root 2x plus 1 upon 3. So when the roots are 0 and root 5, the general polynomial expression sum of roots is 0, product of roots is root 5. So this is nothing but minus b by a which is 0. This is c by a which is root 5. Now because alpha plus beta minus a, it is 0, so definitely b is 0, because if a is 0 it's going to become infinite in the denominator, so b will be 0 and a is 1, so c is going to become root 5. If c by a has to become equal to root 5, then a should definitely be equal to 1. So that is why a is going to be 1 in this case. So the polynomial expression, as b is 0, there will be no quotient, there will be no term with the variable x and the constant is root 5. So x square plus root 5 is the polynomial expression. I hope you have gained a lot of information about how to solve the exercise 2.2 questions for the chapter polynomials. So as we have covered all the model questions of the exercise 2.2, like in the first topic where the sum of roots were given and the product of roots were given, we verified it. 3 questions were done from that. And in the second, where you were asked to find out a polynomial expression where the sum of roots and product of roots were given, we have covered 3 more questions in that. So basing on that, please solve the other questions also. If you're having any doubts, please do mention your doubts in the comment section so that we will be ready to clarify your doubts. And we will be meeting in the next video with another topic from polynomials. So see you in the next video. Bye-bye.